Lesson 7-4, Example 2. Our objective is learning to use proportions to find missing measures in similar figures. So here we have a problem. This reduction is similar to a picture that Katie painted. The height of the actual painting is 54 centimeters. What is the width of the actual painting? Well, here we have this reduction, and here's our picture. We need an actual picture in there. Let's say we have a little ship on the ocean here. There we go. Lovely little painting in there. But it's a reduction. In other words, it's smaller than the original. So I'm going to use some problem solving steps here to come through and make sure I'm totally understanding everything I need to. So the question is the width. What is the width of the actual painting? So width of actual. And this is a small version of it. So we want to know the width of the actual, which is a large version of this painting. So our information here. We know some information about our small picture. We know that it has a width of 3 centimeters, and we know that it has a height of 2 centimeters. We also know some information about the large. We are wondering about the width, but we know the height is 54 centimeters. Okay, that's some good information. So what are we going to use as a strategy? Well, for me, when I look at this, when I see a small picture, and I know that I have one that's going to be larger, I want to draw a picture of that. Rather than trying to keep that in my mind, I want to see it right there on the page. So I'm going to draw a picture. And I know there was a key word up here, and that word was similar. Since I know that this figure is going to be similar to this one, mathematically that's a key term. It means it has corresponding sides and corresponding angles. So I can use proportions to help me out. So one of my strategies is going to be to use proportions. And up here, this is the large, and I know that the height is 54 centimeters, and the width is what I'm looking for. So, thinking about proportions, now that I've drawn my picture, I can think about those proportions, and I can go about solving this. So I know that this side corresponds to this side, and this side corresponds to this side. That means I can set up a proportion. 2 centimeters is to 54 centimeters, as 3 centimeters is to some unknown. We'll call that W. So 2 is to 54, as 3 is to unknown W. Well, now that I have a proportion, I can use cross products. And I have 2 times W equaling 54 times 3, or 2 times W, and 54 times 3 is 162. I'm going to divide both sides by 2 so I get W by itself, and come up with W equaling 81 centimeters. So if that's true, then the following should be true as well. I want to do a little look back here. I want to double check my solution. So I know that if this is 81 centimeters, I can say that it should have the same ratio as this painting. So I can say that the ratio of the height to the width, 2 centimeters is to 3 centimeters, as 54 is to 81, because the ratio between these two sides should be the same as the ratio between those two sides. They should be equivalent if they're similar figures. So I want to just ask myself, is this true? Is 2 to 3 a similar ratio as 54 to 81? Well, if I multiply 2 by 27 and 3 by 27, 2 times 27 is 54, and 3 times 27 is 81. So yes, Those are equivalent ratios, which means that this is a correct solution to that problem.